just a way of recap. Yesterday we looked at how we can isolate, or mechanism through which we can isolate our work environments as a computer, just so that we or we can work in isolated environments. Because as we saw, software installation can be difficult, dependencies are difficult to manage, and you can also have conflicts, and you have different requirements for your bioinformatics tasks, and often these requirements will be overlapping, and you're within a larger ecosystem of software tools, development, technologies that you pretty much don't have control of, really. And you want to make use of all those resources to become productive, often to the glad idea to forge or to foster scientific discoveries, and improve human health and animal health, make the planet better. But we had this major problem. We saw a couple of solutions, and the one that we went through mostly was CODA. That works quite well, but it has a couple of limitations in the sense that one is still working within your computer, and you are restricted to the host environment and operating system. And we also saw that as much as you can share your work environment using your environment file, you may not necessarily have a very fine control of the build itself. Okay, so today we're going to look at another tool, or really it's an entire set of tools, but we're only going to focus on one of them that tries to make this isolation much better. And it does draw inference, I think, from real-world scenarios. When you really think about it, it's not just software tools that need to work in isolated environments. I think often there are always these sort of problems, even in the sort of business world, and there are solutions to that have been fostered. You can always borrow from some of these solutions. So up here I got two images. One of them sort of ship carrying containers, and I think the advent of containers in shipping industry, I think, was a remarkable development. And the idea is just to, I think, for a long time people want to maximize how much you can carry on a ship, and also take into consideration other factors. And this idea of putting everything in a container, then these containers can be stacked, and moved around the globe, where you don't necessarily have to worry about what is within those containers. This ship here could be carrying vehicles, could be carrying items, household items, whatever. But all of that is shielded from us. You can't see it. But the task of ferrying them from one place to another, lifting them, and across ports becomes very easy as long as the items are within a container. And on the right, this so-called sandbox, often used by kids, and the sandbox is a restricted area. The kids can play there and walk around with their items, and this sandbox can be moved around other places. But if you put a sandbox in there, the kids are in there. They feel like they're at the beach or somewhere very nice for playing. And essentially, that's what we want. So you are within the sandbox, and you don't have to worry about what is the outside environment. You can get your things, all our activities carried out within the sandbox. So, sort of the definition of a container is a piece of software that you can use to encapsulate other software components and the corresponding dependencies. So the idea is that you can isolate these environments and work with them. And the whole concept and idea of containerization is to allow multiple isolated systems to run inside a much larger host system. And these definitions are quite important, what you mean by the host, container image, and we'll come down to that. And I did give an example of one of the basic types of containerization, using the shroot command, which can run an application in a jail where it cannot be seen or have access of resources outside of the jail. And it's just basically that concept taken to a whole different level. So the most popular container technologies are Docker and Singularity, and both at the moment are also like spin-off companies by themselves. But we do have others like Podman, illustrated by this thing over here. Podman is largely Red Hat technology for containerization, and K8s Kubernetes technology. So this was released by Google. I don't know who really owns Docker, but it's an enterprise. But this is Red Hat Enterprise, and I think Kubernetes also is largely, I think, controlled by Red Hat, if I'm not wrong. But it is a business on its own. And once you get familiarized yourself with one of these technologies, the others are pretty much drop-in replacements of the same concepts. A couple of things will change, and things like we was talking the other day about security. Has to be taken in consideration, and because sometimes I think of business interests, companies will just spin up their own tools that work and are better supported within their own ecosystems. So today we cover Docker, but there's a lot more in Docker than I'll cover here. So we'll just barely scratch the surface. But then once we familiarize ourselves again with the basic commands, the idea is that we can scale up those commands and make use of them. So, and there's a lot of things that you can do with Docker and with all these technologies that are out of scope of our course, but we will walk through them. So let's home in a little bit about Docker. Yeah. So Docker is an open platform for developing, shipping, and running applications, and it does separate applications from the infrastructure. And I've borrowed this image here, which I think is really nice to sort of illustrate this concept. Is that you have your infrastructure, which would be the physical devices, whether it's your PC or a much larger server. And on it, you have an operating system. That can be Windows, it can be Mac OS, it can be Linux, Unix, or any other operating system. And then you'll install Docker on your operating system. And with that, it allows you to create images, which then can be spun into containers. Okay, and we'll come down to those definitions of what image is and the difference between images and containers. And therefore, your container has an image where you have the dependencies here, the bin libs, binaries, and all the libraries and the dependencies. And then you can spin a container out of it, and that can be very restricted. It can just run a single application. So a real good use of containers actually has been in web development. Lots of websites just run off containers. And again, lots of application in bioinformatics. And what are the benefits for this? There are quite a number of them, really. It's the ability to isolate applications. So particularly in web development, one of the pain points in web technology is security. But then within a container system, you're able to take all that in consideration. Efficiency in terms of the resources. When you spin off an entire infrastructure, an entire machine just for doing one task, that can be really inefficient. You have a lot of resources that are not being utilized. So you can sort of just make use of only what you need. You can increase the efficiency. And also the ability to run multiple applications of the same hardware, you can really, get more efficient. And scalability, the ability to, scale applications depending on the resources that are needed. So you may have a website, you may have something that only is being used maybe by 1 or 2 people, but then over time, lots of requests start to come in, and therefore you're able to scale your resources as needed, and therefore, and also expand, your application as required. Portability, so you're able to port or carry around your application across multiple operating systems, across multiple infrastructure. If you have a Docker image, you can run it on your laptop, you can run on a HPC, if they allow Singularity or Podman, for example. But also you can run it across any other operating system. I can run it over a Windows machine. If you have Windows and you don't have Unix or Linux on it, instead of thinking about, no, what am I going to do? Do I install it? Do I do a boot? Do I install a virtual machine? If you have Docker, you can simply just run that application on that sort of infrastructure or resource. Again, of course, resource utilization, version control, and rollbacks, because Docker images are quite easy to spin. You can pretty much version your Docker containers, your resources, your uses, and use them as needed, and roll back when needed. And I've mentioned about security and cost effectiveness. You have efficiency, scalability, portability. You can almost imagine, cost effectiveness. It's a major application or benefit. So, use cases. You can use that to run analysis pipelines, and I think either tomorrow or later today, John will take us to the next flow, and you can install runtime tools, Python file, name it. Many packages can run on it, Minimap, SAMTOOL, GATK, and yes, you can make full workflows, Cynic make next flow. Web applications that need proxy servers and databases, application code, that require consistent operating system. An example is Galaxy. I think we may have an opportunity to see how we can run and spin off Galaxy instance on Docker and even change some aspect of it. So the big question then is usually, what is it, Docker or virtual machines? Yeah. So which is which? So it turns out that virtual machines are often not lightweight, as you can imagine, because you're abstracting your hardware and you still are making use of a lot of resources. So virtual machines package the entire OS, and therefore there can be a bit of wastage of resources. Whereas Docker uses the host kernel and a very minimal, just a basic operating system that can be shared between the containers. Sort of, this is an image here trying to illustrate this concept. You get your Docker that's running on top of your host OS, the infrastructure, whereas here you have infrastructure, hypervisor, and then you have all these guest OSs, and then you get your dependencies, and then only then can you spin off your application. So here we don't need this guest OS, we simply just abstracting the software needed and are able to run this. So that brings us to these terminologies that we often need to kind of understand them. Quite basic. What is an image? And an image is simply a lightweight, standalone, executable package of piece of software that has everything needed to run it. That's the code, the runtime, system tools, system libraries, and the settings for it. And a container is an instance of a running images. You can spin off, therefore, multiple containers from the same image. Okay, so once you get an image, you can run off multiple containers out of it, because these are simply instances of the image. So several containers can run from the same image, and the host is the machine that is running Docker, on which images and containers are stored and running. Okay, so here again, I borrowed a nice image from this Melbourne bioinformatics organization, and they've got a really nice tutorial as well. And what you see there is, we've got our image, and we can spin off multiple containers from the same image by specifying the Docker run command, and we'll see how that can be done. And just to take it a notch more, is this concept that you've got your host machine and you've got Docker ecosystem. I really like to think of Docker more like a big ecosystem, because it's you've got the software, you've got the runtime, you've got the Docker Hub, and you've got a couple of other things. Entire infrastructure. It's quite a complicated piece of software. So you're able to get all these images, and spin-off containers. And by an image, for example, if I'm on a Windows machine, I need to run off software from an Ubuntu machine or CentOS or something else. I'm able to simply download that image and then spin the container, and I will be running that off the host machine. So, with that sort of introduction, I would like to install Docker, and I'm not sure we've all installed Docker. How many of us have Docker installed? Yes, Docker. You have Docker. Anyone else? No. Yeah, it has Docker. And so I'd like us, for those that don't have Docker, we'd like to just install it, because the next set of tasks will involve Docker. So I'll try and post these exercises in the comments. So if you want to install Docker, you can go. So this is the main website. I also find it easy also, if you do it also, you might want to log in, where is that? Yeah, sign in to the Docker, so that you can access the Docker Hub. And if you navigate here, post it, docker.com, get started. And actually, you just Google Docker, and it'll pop up. And I'm on a Mac OS, but you're able to download Docker for different operating systems. So there's the version for Apple chip, the ARM, and I did run into some issues with this, because I got an ARM machine and realized that there are certain images I can't run from Docker. And you got the version for Windows, and if you're on a Linux machine, you can download one. So let me know once you get it installed, and log in, sign in here, so that you create an account within Docker. What's that? What's that? If you're online. I don't know, but you don't want to do that. But if you're working with Coda, I think it is quite interoperable with Docker, particularly if you're spinning off like a snake make. But I've not done that yet. But you can create these workflows. The other thing that you can do is run Coda within Docker, for example. It does take a bit of setup to get that working, but you can pull off images on Coda. Yeah. I think there are a couple of images that you can get started with. Download So let me know if that works for you, and we can then move forward. First.
George,
Yes.
is everybody connected to the internet? Because I'm not sure people are using computers.
Are we all connected to the internet? Do you all have access to the internet? Is somebody? Yeah. I think that is the just sort it out. So I think depending on your operating system, so I think you just double click and install the application. And on my computer, it gives me this sort of interface. Although we'll be interacting mostly with it on the command line. So I'll show you here. So it gives me this sort of interface, through which actually I can do quite a lot. But we'll try and run most of it through the command line. So I'm logged on. I can pull images. We'll be working with some of these images. So we'll be doing some demonstration. And if you look here, there's a warning. Yeah. Because I'm on an ARM chip, and this image here is optimized for Intel chip. So it's telling me that this is not going to run very well. And indeed, I did try to run that. I'll come to that. In a detached mode, it just doesn't run. So that's just something for us to do. Maybe so let me know when we are all sort of set up. Yes.
Yes, sir.
So if you've been successful, other than for her, that means that you have Docker installed. It's often important to also create an account on Docker Hub, because Docker Hub is going to use that account to authenticate you, just to ensure that you're sort of a real human. So you'll need to register or create an account in the registry and then log on. So if I show you my Docker interface, for those of us that have a Windows system, you'll have something like this, and I'm logged in here within. I have an account there. Yes, please. Yeah, it's like what I'm saying. You don't have to, but for you to download some of this, so if we could try something just to ensure that our instances are running and working correctly. And the way to run Docker, a very simple command would be Docker, which is the command, and subcommand. The same thing we had with Coda, Coda do this and then other subcommands. And in this case, you can do Docker run and then image name. So to just confirm that your Docker installation is working correctly, you can do Docker run hello world. And what it will do is that it will look within your Docker internal repository whether that image exists, and if it does not exist, it's going to pull it from Docker Hub. It's going to run it, and it's going to output hello world. So that's the hello world program is sort of the introductory program for nearly all programming languages. Just to make sure that your system is working, you just want to post to the world and say hello world. So if I try to do it, I'm trying to just
try running that command to see if it's Docker hello. Yeah. It's running Docker. You want the desktop. I think maybe meeting so try running that command. That should work.
Yeah. So if you run it, you should get a message similar to this. Hello from Docker. So this shows that your installation appears to be working correctly, and so on and so forth. Okay. So if you see that image or a message around that, it should mean that your installation is working, and we should be ready to go. Yes. The demons already run for her. Just run it. So she's able to find the image locally. What she will happen is that so now you should run this is yeah. So if you're running on Ubuntu or similar, you try to log into the image and you have an issue to fetch the image, you need to log in through your command line interface. So docker login is the command, and then you ask you for your login details, which would be the username and the password you created. Remember the password? So then you have to go back here.
Maybe you need to do the local login.
Then change your account.
And look at status.
Or request for the password change.
Oh, you're saying you need to log in?
Yeah,
Yeah.
Starts. R2.
Yeah, good. Awesome.
If you can't change
Yeah, so get your username, the one on the login. Yeah, and then the password that you set after the login. You remember what it is?
George,
Yes.
starting the demo.
Just Docker login.
Local login, right? Yeah.
Just Docker login. Docker login. There you go. So put in your username, the one you say, and then the password. Password is the password you created when you created the account.
incorrect using
So make sure it's the same password.
Yeah.
Yeah.
What's your password?
I'm not sure
Use it like that.
When you go use it, it does it once you gives it again. Once you run the money. Use it.
Yeah, suggest
That's true. Incorrect username.
because it did not give me to get started. But I didn't say
Use your
Then use your Gmail
Yeah, use the
account.
Gmail details.
and they shouldn't be doing that.
Yeah.
Yeah, it's true, but sometimes. Yes.
By the way, if you use your Gmail, I don't know if it's the same for everybody, but it's still another because my password, and I know exactly what my password is. So then you have to reset your password.
So,
And will send you a verification link and then you can use it same for you.
so how do you log in?
So no, I'm still, I'm actually, I'm saying, after you log in with your Gmail account, you don't use.
She's saying that you need to
Just like
your full
Yeah.
Gmail.
The password to your Gmail.
No, but I already used it.
So yeah, so you can
Yes,
use
you send my put my Gmail before. So you need to use a Gmail. Yeah, before you work.
Yeah.
I tell you the full Gmail.
Then you just reset it from local account. Just reset it.
Then you send you a new
At least
like that send a verification link.
Okay.
you can't remember your password, right?
That is strange.
But in your password, you don't tell them somewhere.
Unless it's not. Should have used Gmail to log in. But in the settings, I always have a new account.
Always log in. Web interface. Because you stored your password for them. Right now, we should go to. Is it good? Yeah, good password.
We have this awesome tool called Nextglade that you can use to do a lot of quality control. And now that has been extended not just for SARS-CoV, but for a lot of respiratory pathogens and pathogens of public health importance, including measles, dengue, influenza, obviously SARS-CoV-2, RSV. So there are a lot of concerted efforts to scale it for a lot of pathogens. It's really, really awesome tool in terms of the runtime. You can see it has over 100,000 downloads. And this one here, that's the builder. This is the tool, has over 1 million downloads. It has 5 stars. And just like when you're shopping, these indicators can help you to know or tell which are the sort of real resources, because you may go to the registry and people will put up all sorts of things up there. You know, some will work, others will not work. And often you want to go to have one that is highly starred and also one that has lots of downloads. And I also tend to look at updates. So the more active projects will be often updated. So if you see something that last time was updated was 5 years ago, you're on an ALM computer, it's likely that it's not being supported or the developer has abandoned that project. So that's something to be aware of. Maybe we can go for tea break and then we can come back and continue with the next set of practicals. But you could try it on on the Docker Hub on the web interface. You can search for your favorite tools. Here I've given an example of Nextcloud. And also you can go to the biocontainers registry. Maybe I should, yeah, so if you Google biocontainers, it'll take you, just click on the first link. But I'll try and post the link here as well, just so that we are on the same page. So it's biocontainers.pro. Just place it here. Biocontainers.pro will take you to the biocontainers registry. And you can still pull things from that registry. Right. Yeah.
Yeah.
Let's go for tea.